We're looking at the quotient rule, finding the derivative of a quotient. A couple of things need to hold in order to use this rule. So let's say we have two functions, u and v. So let u and v be differentiable functions. So differentiable at x. And because it's a quotient, we need to say that v of x does not equal 0 because it's undefined there. We can say the following, then the quotient u over v is differentiable and the derivative, so d dx of the quotient u over v is equal to the following. So it's not the derivative of the numerator over the derivative of the denominator. Don't want to do that. You're not going to get very many points on an exam if you do that. So in this one, order does matter. So to take the derivative of a quotient, you're taking the derivative d dx of your numerator u times the denominator v minus the numerator u times the derivative of the denominator d dx v all over the denominator v squared. So another way we could write this is if y or f of x was equal to u of x over v of x, then the derivative f prime of x is equal to the derivative of the first, u prime of x, times the second, v of x, times the derivative, or times the bottom, minus the first numerator, u of x, times the derivative of the denominator, v prime of x, all over the denominator, v of x squared. So let's look at an example of that, and then maybe tomorrow we'll have a time to prove it. I don't think we have enough time right now. So looking at one, let's say we had the following. Y is equal to 4 minus 3x all over 3x squared plus x. Okay, so there's no way to manipulate this so that it would make it easier to take the derivative. So we need to go ahead and use the quotient rule. And so again, the quotient rule says the derivative of the numerator, so dy dx, is equal to the derivative of the numerator, so d dx of 4 minus 3x, I haven't taken the derivative of it yet, I'm just writing out the rule, times the denominator, which in our case is 3x squared plus x, minus the numerator, so 4 minus 3x, times the derivative of the denominator, so d dx of the denominator in our case is 3x squared plus x, all over the denominator 3x squared plus x quantity squared. So now go through and take the derivative. So we have dy dx is equal to the derivative of 4 minus 3x. Derivative of 4 is 0. Derivative of negative 3x is negative 3. Times the second, which is 3x squared plus x, minus the first, which is 4 minus 3x, So now let's take the derivative of the denominator. So derivative of 3x squared, bringing down our exponent in front and multiplying by that coefficient. 2 times 3 is 6. Subtracting 1 from our exponent, we get x, plus the derivative of x, which is 1. And we're putting this all over the denominator quantity squared. I'm not going to expand that out. I'm just going to leave it squared. So now let's distribute and combine like terms. And so if we distribute this negative 3, we get negative 3 times 3x squared is negative 9x squared. Negative 3 times x is minus 3x. Minus, so now let's FOIL this out. So 4 times 6x is 24x. 4 times 1, so plus 4. Negative 3x times 6x, so minus 18x squared. Negative 3x times 1, so minus 3x. All over this quantity squared, denominator squared. Let's distribute the negative and then combine like terms. So we have negative 9x squared minus 3x. Distributing the negative inside that bracket, I get negative 24x minus 4 plus 18x squared plus 3x, all over the denominator squared. Almost done. So combine like terms in the numerator, we have a negative 9x squared plus an 18x squared is a positive 9x squared. We have a negative 3x minus 24x is negative 27x, plus 3x is negative 24x. And then the only coefficient I have left is a negative 4. All over 3x squared plus x quantity squared. If I thought factoring the numerator would cancel anything with the denominator, I would do that, but I don't see that happening and we ran out of time. So I'm just going to leave it like that. Any questions on that one?